Good afternoon, ladies and gentlemen. Um, my name is Pawan Karki. I work for the Transport Group, um, but I am now on deputation to work with the ITD department. Very warm welcome to you all. Today we will be discussing and sharing what we have done for the past year on our algorithm platform. At the moment, it's called the ORIS platform, but later as we go along, when in the process of white labeling this, it will have another ADB own name. I also would like to take this opportunity to thank the ITT department to take such a big initiation. Um, Thanks to the leadership of DG Stephanie, Director Ozier, and Mark, who've really made this happen. We will be also discussing with you how we did demo sections on 3 projects in Uzbekistan. We trust that this initiation will solve a lot of our emerging problems in terms of climate change, because as you know, ADB is becoming a climate change bank, but also on the other hand, we are also a knowledge bank whereby we would, have problem-solving solutions to various type of activities for during a project cycle. So now, without much ado, I would like to request DG Stephanie, who's been very kind to spare some few minutes with us. The floor is yours, DG.
Yeah, so first and foremost, a very warm welcome to this event, and I'm very excited to share with you, the conversation that we have about this new launch of the digital twin framework. So, as most of you know, that we are actually at the nexus of climate change, green transport, resilience, as well as digital transformation. So one of the things that we have been always saying is that if we need to do so much work, I think the best multiplier effect is actually digital. And that is where I think we work very closely with the transport team, and also to actually looking at this solution as our first releases of our digital twin framework. So specifically for road, this is actually for the transport project assessment and design platform. And we are very glad that we can share this in this forum, because this forum presents a very good opportunity for us to exchange ideas as well as experience with many people who are in this, transition of the green transport. So let me just share with you a little bit of, the starting of this conversation is that when we're looking at project design, I think, Ori's team have and us, had worked on this one to look at when you actually design a project, how do you actually looking at the cost comparative analysis, the carbon emissions, projections, even so on the road design, how do you actually meet the road design safety and all this? So with this digital twin platform, we were able to actually provide some of the scenario planning for people to look at the design of the road. So that is actually one of a part of our digital transformation action plan, is to be able to help our transportation sector team as well as our regional and country team to work with the respective, governments to look at how they could actually design the road better, and that actually can reduce the carbon footprint and also use more of natural resources and reduce the project costs. So from this, we actually have quite a lot of sharing, which is, I think, the team later at the panel will actually share with you some of the lesson learned. More important, at the beginning of this forum, we launched the Green Road Toolkit. So I was just sharing with the team that, hey, look, now we have this AI-enabled digital platform that actually can already take 6 of the module out of the 9 module. Am I correct? Into this digital acceleration. So to me, meaning is that instead of going through the Excel spreadsheet, now we have this platform that already incorporated a number of the modules inside. So this is something I would say is we are on the accelerations, pedal to actually bring more of the green transport in realizations. So with that, I'm very excited, and we hope to actually get more feedback. And more important is that we want more of the practitioner like yourself who actually understand the ground challenges and how you can actually use this tool to actually make better design, and also to cater for some of the climate resilience, adaptations, and all the measurement into your project. So with that, I thank you and hope you enjoy the sessions. Thank you.
Thank you, DG Stephanie. She's always very kind and very smart in her directions to us. Frankly saying, I've been working in road sector for the last 39 years, and still then, DG Stephanie sometimes and Director Ozer also, they ask questions and I start puzzling how to answer them, and very difficult questions. So I hope they will not ask very difficult questions today. But once again, thank you very much, DG, for your initiation and your great leadership to move this forward, this project so far. And also thank you to Director Ozer and Mark for all the guidance and the leadership. So next in line, we have Monsieur Nicolas. The presentation is basically going to describe how this module, this platform, this algorithm is about sustainability and resilience. Of course, there's a lot to do more, but as the CEO of this company, he will be presenting on the resilience and sustainability of road projects and the experience we had last year in Uzbekistan. The floor is yours, Monsieur.
Thank you, sir. Thank you. Good afternoon, everyone, and thanks for spending a bit of your precious time with us today. I will start by introducing, if this clicks, or maybe you help me with the next. Thank you. Introducing a few concepts. I'm sure you all die from seeing the demo and seeing the live things, and this will come. But before that, maybe a few words. We are of the transport industry, and this transport industry is an industry of projects, which makes it very complicated because it's projects spread everywhere, all different, all unique, but they all respond to the same methodology, though. And this is what we do with the digital twin. It can be rationalized as one industry. It answers same rules, methodologies, calculations, standards, even though from one country to another, those standards can vary, but there are the same rationales behind them. And finally, we can benefit and make it more efficient by adopting best practices from one side to another. And this is true for a department, for a country, and even at the world scale. So there are best practices to exchange in that sector. Maybe we go next slide, please. Okay, so here's the question. And we are used to say this is the impossible equation. because traditionally the road industry is starting with very mechanical concerns. So how much my road will last with this much traffic and with those soil conditions, etc., etc. But from those mechanical perspectives, we went to a number of additional constraints and factors that we need to consider now. So those are road safety, natural resources, circularity, managing the cost, the life cycle, the whole life cycle, resilience to climate change, etc. You name it, because the slide is definitely too small for all of those. But all those parameters make it very complicated. It makes it really impossible to have the right equation. So this right equation requires digital. It requires iterations. It requires computing power. Otherwise, you cannot really get it right, or you have something acceptable, but maybe not the best of the options. So that's also where the digital is inviting itself in the sector. So that figures out how it works also in terms of three very solid pillars of knowledge. And we are describing the foundational architecture from a sectorial expertise. Construction material knowledge, because construction are critical to the road sector and to the transport sector. I will just give you two numbers, two figures. 40% of the construction materials are going into linear transportation, 40%. So if we want to take care of our natural resources, we better have this equation right. And the second number is that 85% of the carbon emission is coming also from those materials. Which type, which property, which distance, what is the overall pavement articulations, etc. 85% of the carbon emission. So those two numbers are really pointing at, let's have the construction material expertise right in our project, first block. The second block is the transport expertise. Of course, we need also to control, master, and be very well compliant with the policy, the different country expertise. We need to have capacity building in that and really spread the best practices. And last but not least is the environmental science, which is also rising in terms of capacity. And this includes circularity, this includes resilience to climate change, this includes a lot of very particular expertise that we will see later in the demo, which were not in the room 10 years ago. They were definitely not in the room. So now they are present, they are in front of us, they are actually our challenge, and we need to integrate those in our thinking and in our designs. So those are the three expertise you will find across the different modules. As a foundational layer, you have the technology and digital. And this is very important because technology and digital offers not only the scalability, because that will be the challenge, but it also offers the security, it offers replicability, it offers information management, and a lot of things that we also traditionally have a hard time to replicate because, again, of this world of projects. So digital is also an answer to so many other things. So why should we do that? You have a few figures again here. The infrastructure industry investment per year, it's about $1,000 billion. I take it rounded. And there are tens of billions of dollars of savings to make out of it, to make it efficient. And this is really something that we should be focused on, because this industry is spending a lot, and this spending can be also allocated to more social programs, to more social impact. And for example, we can bridge the gap with rural roads being always a challenge. It can increase capacity also to climate financing because of this improvement and efficiency. And finally, there is a lot in terms of circularity and natural resources saving. And here I put also a number that we should have all in mind. 50 billion tons of materials is the quantity of materials going into infrastructure each and every year. So that's really a lot. Our natural resources are not limited. Our needs for infrastructure is quite limited. So we need to balance this equation as well. And that will be my last slide to introduce then the more practical exercise. The ORIS platform here is figuring how we share information. The pyramid or the triangle here is really from public authorities and financing bodies, international financial institutions, really starting the project into a value chain that goes to more people, more engineers, more contractors, more technical experts, and going down to those famous materials, material suppliers, materials facilities, asphalt, concrete quarries, cement, whatever, steel. And this is a lot of people. And all that should work as an ecosystem, because otherwise we are really sequencing the things and we cannot or hardly optimize. And the typical value chain is really designing things with less knowledge on the materials. And with ORIS, and that's the meaning of this figure here, we can circulate and distribute the information at the right level for the right use all along the value chain. And this is the same for materials information, climate information, resilience information, safety features, etc. And all those things are driving the project from the beginning, early stage, with information that we can use to drive the best decision. I think I will let the floor to a demo, but before that, maybe Mr. Young is going next, right? Yeah. Please. Thank you.
Thank you, Nicola. Very good presentation, and you could summarize in a way that what we have done and will do, but we'll speak more in details in the next presentations. So now it's my turn to give a short overview of what we did in Uzbekistan. Can you please upload the presentation, please? So while they're uploading the presentation, just to tell you that it was quite a challenge in Uzbekistan to do this climate change assessment. We have like with other MDBs, as you know, from 1st of June last year, to have a projects aligned with the Paris alignment. And this was one of the first projects that we had to come up with different factors and different assessments. Next, please. So this project in Uzbekistan is located in a place called Kargil, Pakistan. And Kargil, Pakistan is about 30% of the total land of Uzbekistan. It's a big region. But as you may have read, it's also full of environmental challenges in Kargil, Pakistan. So we did, this project is also important because it links to, it's a Karachi corridor, and Uzbekistan is doubly landlocked country. So you can imagine exit to the sea is very important. And they want the fastest route to get to the sea. So without going through Russia, this route could go through Kazakhstan. Another big problem in Kazakhstan with all the climate change and biodiversity issues, environmental issues. So we were really, really struggling to increase both the adaptation and mitigation measures for which the client was not very happy to borrow more money on climate change, but ultimately we could show with this platform how we could do a calculation of overall life cycle costing, which was considerably reduced when we introduced those systems. So there was the pavement design, road pavement design. As you know, the Russian system of road pavement design is based on the elastic modulus, which is very time consuming, and also it is not economical if you look at the British or American standards. So there had to be some adjustments made in the pavement design. So we used value engineering to decrease the pavement thickness, but introduce innovative geotextiles and geomembranes and other materials that had values. The road safety analysis was done, and IRAP is a partner of this platform. So we could, collaborate with IRAP and get those road safety features introduced in the algorithm in the project design. So climate resilience also, as I said, this was done for climate change analysis at 40 years. So also huge savings in the adaptation and mitigation measures. And road sustainability could, in terms of road sustainability, it could save 6.9 million tons of CO2. This is 17% from the base design. So this software can also give you not only the quarry sites, but the consumption of water and construction materials, which essentially is very valuable when you speak to the client, or when you go to the board. Our board of directors must approve. So these kind of data are very valuable, which the platform can produce. Next slide, please. So in 2022, we had, from 22, we had various presentations, and again, thanks to our DG, Stephanie, who took all the leadership in arranging these kind of webinars and a big presentation with the government of Uzbekistan. Also on the green roads for water, our work was evaluated, and we were awarded among the 3 awardees, one from Kenya, another one from South America, Colombia, I think, and one was awarded for us, to us. We have also produced in parallel several publications in ADB, which is related to this artificial intelligence, one of which you see, Building Greener Resilient Transport Infrastructure. Next, please. So what we are doing here, just to show you what we have done so far. So 8380 pilot project 1, and then 4R180 number 2 has been pilot tested. And rural road resilience sector, my colleague Yong will present this after Kate. And then preparing road modernization projects also in Uzbekistan. And then we have another project in Kazakhstan where we will be doing similar works, going through the platform, producing reports and on the aspects that I just described. Next slide, please. Yes. I think they're saying, okay, stop, you're talking too much. Yeah. So now we have the next speaker is Kat, and her presentation will provide an overall view of an artificial intelligence digital platform to conduct this climate risk assessment. This was done for the rural roads, and we had a big network of rural roads, 7,764 kilometers of big network in Uzbekistan. And Kat helped us. She's a climate change expert, our superstar in our team. And she really helped and spent a lot of time and efforts assisting us, helping us on the climate change aspects. Please, Kat.
Hello. Thanks for the very generous introduction, Pawan. So my presentation, actually, Pawan already gave a very good introduction on this project because this will just be a continuation of what he presented. So for this one, we will be focusing on the CAREC modernization project. So this is, again, as mentioned, this is part of the 380 road network earlier presented by Pawan. So for this one, for specifically for the road project, this is covering 92 kilometers. So it is part of the straight alignment. I will show it to you later on. And this is part of the segment, one of the segment of that alignment. And here, this is a project that we are currently reviewing. So it's not yet board approved, but later what we will be sharing with you would be the process that have been undertaken in order to conduct the climate risk vulnerability assessment. And again, for the main objective of this road would be to foster domestic and international trade towards, of course, regional cooperation. Because as I've mentioned earlier, this is part of the CAREC partnership. So for this one, just to probably differentiate how it was done in the earlier project in 380. So this one, we focused more on looking into network analysis. Because what we usually do for CRVAs or climate risk vulnerability assessment, we focus on the segment of the road that we will be supporting or financing. So like for instance, if it is a 92-kilometer road, usually the CRVA is done for that 92-kilometer road. So here, before we deep dive on the 92-kilometer road, we first assess the entire network in Karakal, Pakistan, to see to what extent of Karakal, Pakistan would be vulnerable to climate impacts. So here, just to show you the process, so here there are 3 elements that we looked at. First is doing the climate screening. You're very much aware of this, looking at the hazards that the project will be exposed to, whether that's heat, freeze and thaw cycles, flooding. So later you'll see what are the type of risk that the project will face. And then we also looked into the infrastructure vulnerability. So looking at the road network, what type of material was used in that road, and then looking into social and economic impact identification. Because for this one, road, as you know, while it facilitates trade among countries, of course, this is also used for mobilization of people or mobility of people. So it has that aspect that connects them to the facilities that are necessary for their day-to-day lives. And we just noted there the GHG emission calculation, because while for CRVAs, it's usually focused on resilience, we are also requesting to include the GHG emission so that in the entire report, we both have the adaptation and mitigation aspects. So again, as mentioned by Pawan, for the entire road network in Karakal, Pakistan, it covers 7,766 kilometers. So here, I'm not sure if you can see, but this is the part that this project will be supporting. So this is the 92-kilometer road. And here is where the earlier presentation of Pawan, this is the road segment that has been prepared for the earlier projects. And then this is the entire 380 road network. So basically this entire alignment. So for this slide, I will just be presenting to you some of the results. So basically, I will not go very detailed on what goes with this, but just to share with you, like particularly for the region, these are the results that we got. So first, as mentioned, for the climate risk screening, we have identified four major climate risks. So basically heat, precipitation, freeze-thaw cycles, and then flooding. So heat, it is very, very important to factor this in because as you know, increase in temperature is expected in many countries. That's based on global projections. And it is an important factor when we are identifying materials that we will be using for road development. Precipitation, again, this is very important. Although in Uzbekistan, global projection shows that there will be a decrease in precipitation rates, but we have to also note that there are some segments in this A380 road alignment that are historically floodplain. So those are very important or very critical for us to identify so that we will be able to identify appropriate adaptation measures. And then the freeze-thaw cycles, again, this is an important consideration because it affects the performance of pavements, particularly its resistance. So here, the cycles are expected to decrease, but still there is this impact in terms of how to maintain or how to ensure the longevity of the roads. Because when we expect more vehicles to travel or traverse this road, and it will be exposed to this kind of risk, of course, the road will age faster. And then again, flooding. If you can see here, the original alignment, it's very close to Amodaria. So the new alignment will now be will not pass through that Amodaria. So it will move away that direction. So, but this is a very important consideration because again, it will cause a disruption and failure when this is not considered systematically. So those that you can see below would be the portion of the roads that are rated as high or extremely high. So here, for the infrastructure vulnerability, we consider three factors. One is road condition, rural connectivity, and time user delay. So for road condition, these are basically, as mentioned to you, basically what are the materials used for pavement. And it also take into consideration, like for instance, if this is an all-season road or not. And then for rural connectivity, it basically looks into those population that are within very close range to the road network. So it looks at about 20 to 25-minute walk type of distance. And then for the user time delay, this is an important consideration because here you look at what would be the impact of, like for instance, if there is a risk, a climate risk that will block a particular road, how will that affect the intercity movement or mobility? So again, same for the those that you see on screen, those below. So basically, those are the summary of the length of the road that will be considered as or rated as those. So for economic and social impact, well, this is very much related to the rural access, but this time, this is identifying the mobility of people to go to facilities, so to social infrastructure facilities, like for instance, hospital, schools. Also, for economic, is more of the proximity to industries, manufacturing, also going to bank. So those are some considerations that are being factored in this particular analysis. So this is just to show you the overall, like for instance, the overall result. So basically, out of the 7,766 or that were earlier mentioned, so 25% of that would be high to extremely high. Just to summarize that, it is very useful to have this type of analysis because it provided us a very holistic view in terms of consideration in terms of measures that we will be considering for adaptation measures. And here, the important consideration that we need to understand would be this type of analysis should be done upstream. So meaning you should be doing it prior to your preparation of project design, because the result of this are very important to inform how you will design your project. And looking into the findings of this, you will be able to also design the project in such a way that it will include or factor in how to build resilience of, like for instance, the road network that we will be supporting. So I think that's my last slide. So there, very happy to join the panel later and discuss with everyone if you have further questions or clarifications. Thank you.
You can take that. Thank you very much, Kat. And I'm really amazed to see how to see the challenges in Uzbekistan. I come from Nepal, and in Nepal, in a short distance of 20 minutes drive in my hometown, you can actually see, you can actually feel the four climate zones that are. So from very hot from the Tarai, you can go up in 20 minutes, and it's freezing cold just in 20 minutes. Imagine. But what I saw in Uzbekistan is that, first of all, Kyrgyz, Pakistan is full of environmental problems, climate change, the Amu Darya, various lakes. You can go to the internet and see how much the international agencies are helping Kyrgyz, Pakistan to fight the environmental problems. But I also think that looking at listening to Kat's presentation, really the climate change reduction on CO2 is really valuta. It is currency. It's dollars, or even more powerful than dollars. So in the long term, whether we calculate the toll tax, how much it would cost, but in the longer term, addressing the CO2 emissions is really so important for us. And I think we need to do more work on this. So next in line, we have my colleague, Yong Oh. His name sounds very young. And in fact, he is young, at least younger than me. He's a lot more energetic, highly talented. I was his humble servant in a project where we did a project on this rural road. And he's going to be discussing, how the vulnerable roads and how we calculate the GHG emissions, and how difficult it was in terms of convincing the client in Uzbekistan, because the indicators are not so strong on climate change. And by the way, in all the STAN countries except Kazakhstan, I think the indicators are not very strong. And how difficult it was to convince the board. So the floor is yours, Mr. Young.
Good afternoon. My name is Yong Guno. In short, Yong, as introduced by Pawan. So hope my face look young as anticipated. Anyway, thank you so much for the warm introduction by Pawan, and also it was my indeed it was my pleasure to work with Pawan and the great team from Oris and my colleague Kathy here. And so can you upload the presentation? Yes, what I'm going to present is about a project in Uzbekistan, which it is rural road. And in Central Asia, ADB has not financed any rural road project before this project. So it was kind of pioneering in terms of financing the rural road. And then if you remember, effective 1st of July last year, ADB introduced the Paris Agreement alignment for all sovereign projects. So when we were processing this one, we had to think about how we can come up with good design that can go with the Paris Agreement. And yet, when it comes to rural road itself is very social and then a lot of benefits to the rural communities. So other multilateral development banks like World Bank or EBRD, they don't require Paris Agreement alignment kind of a condition for rural road project. But then ADB is so rigorous, and then we want to be a climate bank, so we have not introduced a kind of blanket approval or blanket, sign off for rural road. So anyway, we had to think about the project design that can go very well with Paris alignment. And moreover, when you think of rural road, it is not very complex in terms of technology. Any experienced contractors can come and then build the rural road. But the social attention may not be that high onto the rural roads once they are built, because rural road is of course located in rural areas, and then the voice of the people in provinces may not be heard so much. So it should be very, very important to design the project from the beginning very well. So we started from there. Now, so this project, in terms of financing modality, we call sector loan, by which what I mean is we come up with a sample project, sample roads that will represent the whole rural road that the project will cover in the end. So the initial project, or batch one, comprised of 150 kilometers of rural road in 2 provinces, Jizak and Sardaria. So for that, this project has 3 batches, but the first initial batch is about 150 kilometers. The whole rural road will be covered 700 kilometers with the 3 batches. And as I said earlier, the angle that we had for this project with respect to the climate change is how we can make the selected roads climate resilient over the time and over the life cycle of the road assets. And so, yep, and how we did it, these are the climatic risks that Kat has already explained regarding the Uzbekistan case. So we have done the climate risk screening, which informed the important climatic risks like temperature increase, rainfall, precipitation, or freeze thaw cycles, because during the winter, the road and land, when saturated with water, they will compress, and then during the spring, when it gets warmer, then it can expand. So it will raise up the whole pavement of the road. So this freeze and thaw cycle is really dangerous for road asset. So, and then we looked at road structure, drainage, public facilities impact on the population. So these are the cycles that we went through with the project. Okay. Yeah, I'll skip this because already touched. Yeah. Same. Yeah. Okay. This needs some more explanation. So, so rural road, when it comes to rural road project, the biggest problem is how you select rural road. That is the first question that you have to pass, because the local communities have their own wish list. They want the road near their houses to be reconstructed or rehabilitated. and there are other, agenda from the municipalities, and also the central government. They do have their own agenda also. So we have to coordinate. We have to look from a holistic view. So the first thing is the criteria, the minimum requirements and prioritization criteria to select the road. So we had a set of criteria, like what kind of road we want to rehabilitate in terms of rural road, because rural road has also separate categories, and then what would be the eligible road in terms of the road condition, and how about the socio-economic impact. For example, the road that will serve more population, that should be prioritized, yes. And then how about the climate impact? The road that could be more impacted by the climate events, then that should be given more priority. So we started from there, but we had a lot of back and forth battle with client, and Pawan and I had this kind of initially struggled to agree to certain list of rural roads, and then we finally we were able to convince the clients to agree to the set of criteria and prioritization requirements. So with that, the ORIS, we talked with ORIS to conduct a high level, network level simulation, for example, on a certain province like Chizak and Sirdarya, the result of which identified certain sections of rural road that are highly vulnerable or high vulnerable. And then the results is shown here, like Chizak, and you can see here on the x-axis, and then horizontal axis vulnerability score on the so climate exposure on one angle, and then vulnerability score. So you can see on the top right hand corner the most severe impact in the Goptin and Novoka district. So this way we were able to identify the vulnerable roads, and then those were included in the rural roads that we were going to reconstruct. Yes. So, for example, Zizag and Sirdarya, in terms of percentage, highly, extremely vulnerable and high vulnerable roads were identified, accounting for like 24%, and also even medium risk was about 62%. That's very high, and that has been this has been enabled by the technologies that ORIS has, and then was very, very useful informing or designing the project. Yes, next. So the end result is this. You can see little roads here and there in two regions, two provinces like Chizak and Sirdarya. So with this project, we are going to reconstruct the 700 kilometers of rural road. In Uzbekistan, we have like 170,000 kilometer rural road. So out of which we'll prioritize 700 kilometers. Hopefully the government will embark on the second phase. And then this good story of the project will be replicated in neighboring countries, because Uzbekistan is the first country that ADB has entered with this new development for the rural road and the community. So so this is it for my presentation. So I would be happy to answer any questions later. Thank you.
Thank you very much, Mr. Young. He's truly young, very, very sharp and very articulated. So one of the things in this project, the challenge, just to elaborate what Young just said, was what do you do in this kind of circumstances where the government is saying, we want concrete roads, even for rural roads? I know in the Philippines, you have concrete roads on rural areas as well. In my country, in Nepal, also very simple roads are being constructed of concrete. When we looked at the life cycle costing, it did make sense to build concrete roads. But just a small research from what derives is that asphalt roads, after if you lay more than 120 degrees, will deteriorate at 4 times faster than a concrete road. So this is a research that was done recently, and we could also justify with this theory that we go for concrete roads. Concrete roads in ex-Soviet republics are extensively done. But some countries have come back to asphalt. Just for an information for you all, Kazakhstan is rethinking, and they have basically stopped doing concrete roads. But for Uzbekistan, where there's cement factories, 7 cement factories in the country, they have large potential for concrete roads. So I thought I would just share this with you. Thank you very much. And the next presenter we have is Mr. Hugo, and he's the very, very technical person. Also, his name is not Mr. Young, but he's also very young, very talented, very quick in solving the technical problems. Over to you, Mr. Hugo.
Thank you, Pawan. Thank you, Young, Kathleen, and Nicolas. So with this introduction, I will try to do my best. And when Nicolas, my CEO, where we have spent quite a journey since 2017, asked me to make a live demonstration on this platform. What is it about? I wonder how I can surprise him, how I can make it more digital. So I asked to AI to support me. And I would like to introduce a friend of mine to present this video.
Welcome on the Auris Materials Intelligence Platform. Together, we will start the journey through a demonstration of this digital platform. Auris aims to enable the construction sector to design inclusive, efficient, resilient, and low-carbon infrastructure projects. How? By making the most of local resources and social and environmental data, connecting them through digital solutions such as AI, data science, and engineering. This platform is at the crossing of 3 expertises: materials knowledge, environmental science and infrastructure, engineering, and digital technologies. Built on these expertises, this digital platform, Auris, provides data and insights to support the infrastructure sector build more safe, sustainable, and resilient. The heart of Auris is to connect projects to their local environment, hence all projects are geolocated. Today we'll explore projects in Central Asia. Here the 25 kilometers rehabilitation of the A380 highway in Uzbekistan. In the section context, user will input primary infos of the project such as location, alignment, length, width, and traffic data. The second step will be to add your design scenarios. This project was designed with 5 alternatives rigid designs. They were proposed based on local design standards, but could also be enriched with innovative designs. The third step will be to source the materials around the project. This phase starts with the identification of the materials production site around the project, including concrete plants, asphalt plants, cement plants, quarries, and all needed materials for the pavement. After launching the calculations, the platform dashboard will support the selection of the best scenario for the infrastructure. This first dashboard presents the performances of each designs based on carbon emissions, technical costs, and natural resources consumption. The design's global warming potential, also called carbon emissions, is based on 3 pillars. Material production emissions, also called A1 to A3. The second pillar is the transport emissions, A4, from the material supplier's gate to the project site, and the last one is the material laying, A5. Budget costs are built on the same pillars as the carbon emissions graph. You will find material cost, transport, and application. Thanks to the chart pie, you can also explore which layers are the most impactful. The materials dashboard also identifies the most impactful layer and where circular economy could make sense. Now, welcome to the segment overview dashboard. This dashboard aims to present side by side the performances of each design. Each bar represents one design. This dashboard presents the global overview of the results. Based on the project objectives, this dashboard will support a comprehensive assessment of all scenarios. The ORIS platform supports an holistic assessment at construction stage, but also for the entire life cycle. For this project of a rural road, the 4 R180 in Uzbekistan, the assessment compared up to 10 alternative designs for the pavement, all linked to a maintenance program. Based on the same dashboard as for the A380, you will find the maintenances program and their impact from construction till the end of the infrastructure life. Those results cumulated will support a decision-making with data all over the service life of the project. It's noticeable on this example that the most expensive and with higher carbon emissions scenario might become the best alternative option over the entire life of the pavement, thanks to a reduced need of maintenance and lower aging behavior. In addition, ORIS can assess multi-section project. The following project is a rural road program covering 2 administrative regions over 150 kilometers. All sections have been designed so the project can be assessed over its entire portfolio. The global GHG quantification and natural resources uses are displayed. Once the best scenarios are selected for one project, this project could be compared to another project scenario. This comparison could support alignment or low-carbon strategies decisions at project level. Also, the ORIS platform aims to support road safety design at early stage of the project. The International Road Assessment Program, IRAP star rating, is displayed in ORIS. Through it, ORIS can compare the various sections. It then locates the countermeasures possible to improve the safety and reach the UN road safety standard of 3 stars or more. We're still looking at the A380 project, located in Uzbekistan, and for which ORIS Resilience module has been used. Once we're in the project, we can select the Resilience icon and see all the climate exposures calculated for this project. Here we have the heat for the current scenario. We also have the possibility to see the future and the evolution scenario. It is also possible to see the results for freeze-thaw cycles and for precipitation for current, future, and evolution scenario. You can then see the adaptation and mitigation measures proposed directly in the ORIS platform. For example, if we scroll down, we can see all the adaptation and mitigation activities proposed, as well as their cost and their quantity. Directly in ORIS, the user can then see its project climate risk report. Here's an example of a network assessment report with a detailed view of all project aspects. In the Climate Screening and Exposures chapter, user will find climate models, pollution scenarios, and a detailed overview of the network links that can be impacted for each one of climate exposures assessed. Now, in the Social Score chapter, user can check the total population impacted by the project and which public facilities have been considered when calculating the social impact of each network link. In the conclusion chapter, decision makers can check the overall impacted infrastructures, including those classified under high or extreme risk. They can verify how the network links score in each methodology score, giving a united score with climate, infrastructure, and social score. Looking ahead, we're excited by the endless possibilities and the impact we can achieve together. Join us as we continue to innovate and set new benchmarks in our journey ahead.
I would like
Welcome
to
on
thank
the
my
Oris
dear
Materials
friends.
Intelligence Platform. Together, we
As I was saying, thanks. It is my day. And also, this is the aim of the ADB transport platform assessment, to ease the work to assess the infrastructures toward the lower consumption, toward the lower carbon emission, and toward the resilient infrastructures. Back to the discussion about which pavement to select. This platform will ease also the decision. It's not about a dogmatic approach to say, I want asphalt or concrete or any type of pavement. Each project has its own location, each of the project has its own challenges, and the platform will support to assess what is the best solution for the project to climate proof and to ease the process. If you can send the video where I will do a live for this time. I want to come back on the 8,000 kilometers that Kathleen described. This 8,000 kilometers could not be assessed without the support of the digitalization. Before, we were doing that manually on Excel sheets and so. Here, this is not anymore the question. The question is how we can assess a full network and then direct the investment toward the needed location. So we select the best KPIs. We identify the KPIs, like where are the hospitals, where are the schools for the benefits of the population, where are the manufacturers and industry, where there is employment. And on top of that, we will assess where there is a risk of failure of the network, which lead to the population to not the population cannot reach anymore these locations. You can move on. So we can see here the different location, and this is the data acquisition is critical. How we can collect this data manually? We cannot. Digitalization with support from AI, different various sources of data are channeled towards the platform and will allow to make a global assessment of the risk for the infrastructure. Thank you.
Thank you, Go. One thing that that I would just like to underline here is that when we looked at the materials quarry sites, which is one of the main features of this platform, we saw that with PPFD, we were looking at the sustainable procurement, which is the latest innovation. And one of my colleagues, the PPFD guru, Monsieur Didier, is also here. We looked at the grid factor. So what conclusion we made there was it was 0.71, the grid factor. So 0.71 means we're right at the border. So the solution was to introduce in the instruction to the bidders that they make use of special vehicles, trucks, and all that in construction to use maybe green vehicles, e-vehicles, e-trucks. That didn't become possible, but at the moment we're talking to various procurement people in ADB, and one such project in East Asia may be possible. So we're looking at those innovations in construction sites. So I just thought to make this small point. Khurshid, you are staying at the back of everybody. You should come and stay here. You are one of the superstars. Khurshid was my boss in Uzbekistan, my local counterpart who took me around in Uzbekistan and taught me a lot of things. Thank you very much, Khurshid. So if I think I'm the last speaker, please don't go asleep. Bear with me for a few minutes more, and then we'll be done with this. So yes, I know it's 5 minutes. Yeah, so it's really like a football team, right? Okay, you got 2 minutes more, or you go and see the screen. By the way, I'm very, very annoyed with my team, Liverpool. And with Colin, we have this common team, it seems. We did very bad, but anyway, let's see. Next season, those who are lovers of football. Okay, so I just run you very quickly through. So this is what we did in last year with this algorithm, and the way forward with this, where ADB has the successful consultant were Oris, so we're going with them to do this white labeling of this algorithm. And as we go along, if there are any features that we may have to introduce, it will be done. I say we, but really, I will be leaving ADB end of May to join AIIB on the 1st of June. So it makes me really, really sad to leave all these lovely people here in the hall and this big building, but new challenges are ahead. So, okay. By the way, I didn't leave ADB because, I was bad. It's corporate regulations that after 62, you need to retire. Okay, let's go to the next one. So very quickly, a couple of slides only. So what I'm trying to show here is the digital transformation showing sustainability and its operational efficiency and climate change is very much the strategy 2030. How do we become a climate change bank, and what the focus is, and also in the OP3, the tackling climate change, how we build a climate resilient road infrastructure. Now, if some of you heard, I think the road infrastructure is, the road engineers like myself, we are very complicated, trust me. The energy people have straightforward things, so it takes less time to convince others. We road sector guys, we are a little bit complicated in many sense. So we're trying to simplify this. Now, when we say simplify, as you may appreciate now, this algorithm is doing many disciplines with one platform. So, before you had a lot of softwares doing a lot of things, right? Some were doing the due diligence, so to speak, on climate change, value engineering, road safety. So you bring everything, and in no time you do all this with data collection. Especially if you think about it, we are resuming our operations, I'm told, in Afghanistan. And imagine you're staying here and you have a project in Kandahar or Spin Boldak or somewhere in a very remote area. And then you have to do data collection, which is next to impossible. So this platform can do the basic data collection, and it can solve your problems. Next one, next, please. This is how we look at the white label. And thanks to Director Ozier, who had this fantastic idea, of coming up with this white labeling and make it use like one of the aids, one of the elements of IT in ADB, like we have the eObs, we have the travel softwares, different softwares, to give a possibility for every ADB staff to use it in their daily works. So if you see, we were traveling. So the bus is, if you like, the Uzbekistan first project, second project, we go in a car, motorbike, and then it goes, you know, on a BMW or Mercedes or whatever. So that's the idea. So we are now in number one, and then we will go, the whole process is going to take till the end of the year. Next one, please. So I will not speak in too much detail about this, but this is what, you know, project decision drivers are. Pavement design, Mr. Hugo talked a lot on that, on natural resources, carbon footprint. Kate talked about that on climate resilience, Mr. Hugo. So it does also project management, waste disposals, you know, you can see everything in one map. Next one, please. Yes, so this again, optimization of pavement design, natural resources, carbon footprint. In fact, we have a calculator, so it's not so complicated. You know, it's a very user-friendly. And I remember we also have a calculator where you give the name of the tree and the environment, and it'll tell you the carbon emissions, cost management, climate resilience, road safety, genre analysis, transportation analysis, climate resilience, and road safety due diligence. So you can see that this is an ideal kind of thing that you would like to use after a detailed design is completed. It's quick, it's accurate, it's very fast, and the board of directors love it. So for the government and for you know, the ADB, this is a very good tool. So this is just, if you like, a checklist questions that before you go to the platform, you want to see and convince yourself. Next slide, please. Okay, we're done. Thank you very much. So if there, sorry. Director Ozier will go after we finish the questions and answers. If that's okay with you, sir. Thank you. So any questions that you may have? Yes, please.
Excellent presentation. Dan Agustin from Mindanao. Excellent presentation. Thank you so much for everyone. Now, this is from the financial viewpoint. You mentioned the project costs, okay? Total project costs. May I ask the return, please? What's the return, percentage return on this project cost? And another question would be on the digital system. If you have the project costs itemized, how much percentage is the budget for digitalization on the entire project? Thank you very much.
Thank you. Can we hear a few more, if any, so that we can combine perhaps the answers? Anybody has anything to ask? Yes, please. Yes, sir. Can you introduce yourself first?
So my name's Brendan Coleman. I'm a climate change specialist in the Climate Change and Sustainable Development Department. I just had a very quick question, and thank you for the really impressive presentations of the platform. On the data acquisition element of the platform, I understand that you're using AI technologies based, I'm guessing, based on satellite data. If you could just maybe elaborate a little bit more on the sort of extent of automation of that, and maybe also on the accuracy and the sort of quality assurance that might be needed sort of after that. That would be very, very welcome. Thank you.
Thank you for both the questions. The last question is $1 million question, but we can share what we did. Yeah. Yes, please.
Hi, thanks for the presentation. My name is Christina Chung, and I'm also a climate change specialist, working primarily in the Pacific region. So I found this really interesting and with a lot of potential for the work that we're also doing. And I've been also supported by Kate in a lot of our work. So I just wanted to ask a question about the A380 project. You mentioned that a specific section of the road had been identified for the project, but then you did a wider network analysis. So what was the impact of doing the wider network analysis, and did it have any did it lead to any decision around what to do in the project if the actual road had been decided, from the start?
Thank you.
Thanks.
Yeah. So any more, or we can go to respond? Okay, I think we will respond to 4 of these questions. And so the first one is, Nicola, if you want to go first, and then Hugo may want to add, or for that reason, Kate or Young and myself. So let's talk about the cost and project return and the cost of digitization first two, please.
Does it work? Yeah. Thank you for the question. It's actually a key question when engaging this. So I will answer you in general, because what I will tell is also applied here. So the value engineering that the platform offers is actually comparing different scenarios, different materials, different distances, and this turns into a very technical cost saving on the project from one structure from another to another. Road engineers know that very well forever, because this is the bread and butter of our industry. So now what we do here with this platform, that we offer this capability ahead of the game at the owner level, at the project founder level, so that the project is going straight to the right direction. So that's just to recap on the why. How much? Usually, compared to the original investment of digitizing that, which is 0.something% of your project value, it's really low investment, you recover it 20, 30 times, because the savings that these value engineering mechanisms offer, it's 5, 10, 15, 20% of the pavement value. So it's a lot of potential also from a value engineering perspective. I'm not talking here about the other indicators, but I think you get the range of your answers from the investment point and from the return also you get.
Young, do you want to add on the economic return? I think it was a very impressive EIRR, right? Maybe you're a genius on finance and economics. So yeah, do you want to share what we did?
Yes. The economic analysis, to be precise, I should have the result regarding with and without the digitalization application, but I don't think I have that one with me now. But to the economic rate of return for the rural road, the 150 kilometer, it came up with like almost 20%, which is very high. And why is that so high? Even though the pavement was cement concrete, which is higher compared with bituminous pavement. That is because there has been a lot of induced social benefits thanks to the vulnerability assessment, which looked at not only climate change impact, but the impact of it on the rural communities. So not only the benefits from the renewed road, but also the benefits anticipated toward the community. So it was very high. So
yeah, Thank you. Thank you, Young. I hope, sir, we answered your questions. Thank you very much for this very interesting question. Now, there was one question from my colleague from climate change, where the data was collected and the accuracy. Hugo, yeah, please go ahead, monsieur.
Hello. Thank you for this really interesting question. The accuracy, it's a really key point in the process, and also to deliver an answer to the questions. First of all, I would like to say that the downscaling also from a climate modelization, which is a countrywide or on one region, is not accurate enough for the location of your infrastructure. If you want to modelize the flooding, if you want to modelize the heating according to the slopes, if you are more heading north or south or east or west, your infrastructure will not behave the same with these climate events. So we don't scale according also to the topology of the infrastructure to have really data modelization local. On the data acquisition, it's a challenge because there is many sources of data, and we are here since Monday speaking about climate change and so. And we have seen that the data, it's sourced by many ways. So we have the satellite images to help us. We have the Copernicus model, for example, also helping us. And then after, we make also, on the request of ADB, a comparison of the scenarios, the SSP scenarios. So generally, we compare two scenarios to have a sensibility analysis in between the modelization of climate events we will provide. So I hope this is answering the...
I think one thing we could add here is that besides getting this data from the internet, and I forget the name of this website, can you remind me? We also did in Uzbekistan, we had a guy who would go to the meteorological department, if you remember, and get this data, which was not easy, but it was possible. The name of the source of data is what they want to know.
Oh yeah, that will take an afternoon because it's not one source of data. It's really many sources. But what I wanted to add to that point is that beyond the data acquisition and beyond the data itself, the organization, the structure of this data is critical. And Hugo mentioned the downscaling when it comes to weather and climate data. But when it comes to construction materials, informations and data, this is also critical to have the right structure, organization, architecture of this data. And then once this architecture is in place, actually the number of available informations and data is immense. There are plenty of data quite everywhere. So the question is also to make sure that we treat this data uniformly across the project. So we have a big data team to answer also the question. So the data team is really active, having multi-channels and putting this clean to have proper results.
Yeah, thank you. And I think we also have to give credit to Mr. Abdul Hakim. He's a director with a client in Uzbekistan. We went to university together. He was slightly junior than me, but he was the good man. He used to study very hard. I was the naughty boy. But here we are, client versus financing institution. Please, Abdul Hakim.
The project is mentioned by the Mr. Kolai, ruled by our PMU. It was first project. And now my question that since this year, the EDB, they're changing the safeguard policy. So now the EDB is starting the developing of the standards for safeguards policy. And so my question, do you taking into account this changing?
Very quickly, yes, sure, because those standards and norms that you have and policies, they were already different from the one we use in Germany, in France, in the UK, or in the US. So each country has its set of policies and regulations, and the platform also allows to adapt those standards so that you run on your floor. So you are on your policy. So if there is a change now in Uzbekistan, we will be happy also to implement those changes as a new foundation for the studies.
Thank you, Abdul Hakim.
And your colleague has mentioned that database is very important. So
sure.
So we every country who is in every road maintenance depots, they should make fixing of the all database as climate changing, disasters, floods, and soil sliders. Thank you.
Thank you. We'll make a note of this comment. So the last question we had was on A380. Do you want to answer that, Kate? Yeah, thank you very much.
Christina. So for the value of the network analysis, particularly for A380. So for earlier, we focused more on the result of the regional, the entire Karakal, Pakistan. But aside from that, that's just the first stage. But the second stage would be more focused on the 92-kilometer, which we didn't present. But the value is usually we're used to just, like for instance, earlier I told you that the 92-kilometer, that's the remaining segment of the road that needs to be rehabilitated. So in the usual CRVA, if you do that, you just look into that particular segment and then you do provide suggestions on what are the adaptation measures that would be necessary. But now that we did a more holistic network analysis, you now were able to assess how that road that we will be supporting will be critical in supporting the entire, like for instance, the A380 alignment and how it connects to the other road networks or road alignment within the Karakal, Pakistan region. So you're not just looking at one thing, but you're also looking at how it affects the serviceability of the road. Like for instance, if that road will not be constructed. And then one more point, not just to the A380, but on Yong's presentation earlier for the rural road. So there, the value of the assessment, the road network assessment, would be to help in the prioritization of the next batches of roads that will be identified. Because he mentioned earlier that the government has a list of roads for the first batch. So with the use of this criteria, with the use of the information from the risk vulnerability assessment, those will inform the next batches of roads that will be identified. So meaning we will be able to lobby with the government that they should be able to prioritize those segments that are more critical to climate impact. So I believe those are some very important points that we get out of this system or this assessment.
Thank you very much, Kate. So looking at the time, I think we've run out of time. With your kind permission, I am requesting Director Ozer to come up and say a few final words of our presentation. Thank you very much.
Well, thank you all for coming. It's 3:30, so I'll make it 1 minute. I'll just make 3 quick points. I'm not a transport expert, but I'm a technologist, and a few questions that came up here in terms of digital, in terms of return, and so on and so forth. I can tell you from a technologist perspective that I saw civil engineering going digital in 2010, 12. If you look at other sectors, banking sectors and other, they went digital a lot before. So as you move into digital in civil engineering and in transport, the return on investment you can see, imagine banking without digital. 20 years forward, you will think about transport and digital in the same way. You cannot do transport without digital. Next, second point quickly is on data. Where data is today and where technologies around data, whether it's satellite data, whether it's IoT, your road is going to talk to you. Your transport is going to talk to you in terms of data, and you can collect the data. it was mentioned that you have multiple sources of data and they can now be harnessed quite easily. And lastly, of course, AI is here. AI is here. Just to give you a personal example, again, I'm not a civil engineer or an architect. I just bought a piece of land, well, 2 months ago, and I was designing a house. So what I did was I took the lot design, fed that to AI. I took my own concept, what the road to the house I was going to make, and the type of house I wanted in terms of ceiling. I also gave some geosatellite data to AI, and it came up with an architecture, which I gave to my structural engineer. And he said this has done 60, 70% of the job that he was supposed to do. So just myself, without being an expert in civil engineering, I was able to construct something. So that shows where the world is moving. And I think transport sector is where huge opportunities lie in terms of digital data and AI. So with that, I'll close this and thank you, Pawan, for all the hard work and looking forward to working with you when you are in AIIB. Thank you all.
Thank you, all of you. Thank you, Director Ozer and my colleagues here. If there are anything that we need to discuss, please let us know and we may join for a cup of coffee. Thank you very much and God bless you all. Bye-bye.
Yes. I should not sit in the middle.